this is Mrs. Correa here at John Marshall High School, and we are continuing our discussion on composite figures on the back of our notes page. So it says, use your understanding of composite figures to answer the questions below. Number 1, a rectangle is inscribed in a trapezoid. Determine the area of the shaded region. All right, the word inscribed just means that the shape is inside of a trapezoid. So we have a rectangle inside a trapezoid. And then determine the area of the shaded region means that we're going to find the area of the trapezoid and we're going to take away the area of the rectangle. So area of the trapezoid minus area of rectangle. So we need to find the area of the trapezoid. Let's start by writing down the formula for the area of a trapezoid. And that is adding the two bases, base 1 plus base 2, times the height of the trapezoid divided by 2. Next is to plug in all of the values, replace all the variables with the numbers that they represent. So our two bases are the two parallel lines in the trapezoid, the one on the top and the one on the bottom. So we're going to add together 10 plus 15. We're going to multiply it times the height, which is the distance between the two bases of 8. And then we're going to divide by 2. Okay, so 10 plus 15 is 25. Times 8 is 200 divided by 2 equals 100 inches squared. And that is the area of the trapezoid. Next, we need to find the area of the rectangle. So we're going to start by writing down the formula. Base times height. All right, the base of our rectangle is 7 and the height is 5. So let's rewrite our equation, this time replacing the numbers for the variables. So we've got 7 times 5. 7 times 5 is 35 inches squared is the area of our rectangle. Now remember, we're not done because we need to subtract trapezoid minus rectangle. So our final answer here is this 100 inches squared minus the 35, and that's going to give us 65 inches squared, and that is our answer for number 1 for the area, the shaded region in this figure. Let's look at number 2. A patio is being landscaped with trees and shrubs. How many square feet of landscaping will be around the patio? So in this situation, they don't want the shaded region. They want everything outside of the shaded region. So we don't want this part. We want the kind of L shapes here that we have on the outside, this landscaping. Now, we don't have formulas for L shapes, right? We need to divide this up into shapes that we can solve for. So when I look at this, I actually see, rectangles. So I'm going to draw vertical little lines here to divide our L shapes into 4 different rectangles. So I've got rectangle, let's call this guy rectangle A. And let's call the other one rectangle A, because they're the same. And then we've got rectangle B and rectangle B. They have the same dimensions. All right, so let's look at let's look at rectangle A. And in order to find the area of all the landscape, we're gonna have to add up all of the rectangles together, right? So we're gonna do rectangle A plus rectangle B, but then we have to do it twice. So it's really 2 times rectangle A and 2 times rectangle B, right? Because we got 2 rectangle B's and 2 rectangle A's. All right, so let's go ahead and substitute in our formula. So the area of a rectangle is base times height. And we're going to do that times 2 for rectangle A. And then we've got base times height times 2 for rectangle B. All right, next step is to replace our variables with the numbers they represent. So in rectangle A, we need a length and a width. And so it looks to me like our base and our height is actually 3 and 8. So let's go ahead and write that in. 3 times 8, and then we'll do that still times 2. All right, now let's look for rectangle B. Now, it looks like we've got 3, but then we don't have a length for rectangle B. This 14 goes all the way across, and it includes this extra bit here. So we need to figure out what is just rectangle B. So how much of rectangle B or rectangle A do we need to take away to get this length? Well, we know this length is 3. So if this is 3, what does the other side have to be? It has to be 11 for that whole distance to be 14. 14 minus 3 is 11. So for rectangle B, we're going to have 3 times 11. All right, let's go ahead and simplify and add everything together. 3 times 8 is 24. And 3 times 11 is 33. All right, if we do 24 times 2, we get 48. 33 times 2 is 66. We add this all together and we get 114 feet squared for our final answer. That does not look like a 4. Let me fix that. All right, that's number 2. Let's look at number 3. A composite figure is created using a rectangle and a semicircle. What is the area of the figure? All right, to find the total area, we need to add together the rectangle and the semicircle. A semicircle is half a circle. That'll come into play when we write down our formulas. So we've got rectangle, area of the rectangle. We're going to start by identifying the shapes. And we have a semicircle. And in order to get a total area with the two, we're going to add them together. Oops, sorry about that. All right, so the area of the rectangle, let's go ahead and write down our formulas. The area for the rectangle, or the formula for the area of a rectangle is base times height. All right, let's substitute in the values for base and height. It looks like we've got 18 times 12. And 18 times 12 is 216 inches squared. So that's the area of our rectangle. All right, let's talk about the semicircle. So we know, let's start with the concept of a circle, okay? We know that the area of a circle is pi r squared, but we want half of that circle. So whatever value we get for pi r squared, when we're done, we're gonna divide by 2. All right, let's go ahead and substitute in the numbers that we know. We know that pi is 3.14. And then r is radius. So when I look at my semicircle, what I know about it is I know that the diameter, which is all the way across the circle, is the same as my height of my rectangle. So I know all the way across the circle is 12, but that's the diameter, and I need the radius. The radius is only halfway across. So the value of our radius halfway across the circle is half of 12, which is 6 inches. So going back to substituting into our formula, if I've got r squared or radius squared, that means I'm looking at 6 squared. And then I'm going to divide by 2. All right, so 6 squared, 6 times 6 is 36, times 3.14, divided by 2 gives me my final answer of 56.52 inches squared for the area of the semicircle. To finish up the problem, we need to add them together. So we're going to do 216 plus 56.52, and that gives me my overall answer of 272.52 inches squared for the area of the figure in number 3. All right, let's look at number 4. Find the area of the shaded region. So just like the shaded region problem in number 1, we're going to find the area of the outside shape, and we're going to subtract the area of the inside shape. So the outside shape is a square, and the inside shape is a triangle, and we're going to subtract the values of the areas. All right, let's start with the formulas. The formula for a square area of a square is base times height. Let's substitute in the values of base and height. And our base is 9 and our height is 9. So the area of the square is 9 times 9, which is 81 meters squared. Let's look at the triangle. The formula for the area of a triangle is base times height divided by 2. My base and my height for the triangle is actually the same as the square. It's still 9 times 9, but then when you're done, we're going to divide by 2. So 9 times 9 is 81. 81 divided by 2 is 40.5 meters squared. All right, now that I know the area of the square and the area of the triangle, I can find the difference in order to find the shaded region. So that means I'm going to do 81 minus 40.5 to get my final answer of 40.5 meters squared. And that is the area of the shaded region on number 4.